Okay, hopefully you all had some fun with Mr. Micah and the Skittles activity. So what I want to do is I want to kind of walk through the example for those who aren't here, those need to watch it again. So here is the activity we did. Can you taste the rainbow? Basically what we're trying to determine is like if you closed your eyes and you tasted a Skittle, if you could tell the flavor of it. So I'm just going to use one of the examples that was up on the board. And the example that was up on the board was 22 correct out of 50. So what we were finding out there is that our p hat, 22 out of 50, that's 44%. So we're wondering, is that enough to prove if you can actually taste the different colors? So use the acronym PHANTOMS. P stands for defining your parameter and context. So P would be the true proportion of Skittles you would ID that tastes correctly. Okay, that's our P. Our H, we have two hypotheses. We have a null, we have an alternative. Now remember that the null is always an equal to. Since there are 5 flavors there, we're going to say that P naught is equal to 0.20, 1/5. The alternative, we're going to say that it's greater than 0.20 because if you can, or if you're more than, if you're successful more than 20% of the time, that means you're identifying the taste correctly. Now we get to A, we're going to validate the assumptions. So the first one we're going to validate is random. And in this case, we can make the assumption, we can assume a bag of Skittles is randomly filled. Okay, so we're going to assume that there's randomness to that. Independent. We're going to do the 10n check. So we're going to do 10 times 50, and that's 500. We want to compare that to the population. And we're going to say that it's safe to assume more than 500 Skittles. And the last thing we're going to check is we're going to check the large count. And here's the deal with the large count. We want to use the claim. So we want to say n p naught. So in this case, 50 times 0.2. That gives me 10. That's greater than or equal to 10. Yep. And 1 minus p naught, 50 times 1 minus 0.2. And that is going to give me 40. And that's greater than or equal to 10. So we verified that. And again, the reason we're using the claim is because we're basing this entire test on the claim. When we did a significance, a confidence interval, we were basing it on the sample. Okay, so this one, we are going to conduct a one sample Z test at an alpha equal to 0.05. So we're going to say we're conducting a Z test for true proportion. My mistake. We're going to conduct a one sample Z test for true proportion at significance level equal to 0.05. Then what we're going to do is we're going to use this formula, and the formula is this. The formula is your p hat minus your p naught over the square root of your p naught, 1 minus your p naught over n. And really what I want to see is I want to see this with the numbers plugged in. So what I really want to see, and what College Board wants to see, is 0.44 minus 0.20 over 0.20, 1 minus 0.20 over 50. And then we're going to go and we're going to grab a calculator and we're going to do the test in the calculator. That's going to give us our test and our p-value. So what's going to happen here is we are going to go to stat. We're going to test, and we're going to do number 5. And our P naught is 0.2. Our X was 22. Our N was 50. We're going to look at the alternative hypothesis we had greater than. So we're going to go ahead and take greater than. And what I'm going to do is go ahead and calculate. And what that's going to tell me is I got a Z here of 4.243. And then I got a p-value 1.1 e to the -5. So that tells me down here that my p-value, it says 1.1 e to the -5, but we're never going to write that. We're going to write it as 0.123411. That's the p-value. We don't write that. We write it as a decimal. Now we're going to make our conclusion. We compare our p-value to our alpha. And in this case, our p-value is 0.000011. That is clearly less than our alpha of 0.05. We are going to reject the null hypothesis. So now we're going to state this final statement, and this is kind of like our Mad Lib. Since the p-value of 0.02341 is less than alpha of 0.05, we reject the null hypothesis. We reject H naught. There is evidence to support the claim we would be able to identify the taste of Skittles. We would be able to ID the taste of Skittles. Okay. So again, just so you know, I'm going to kind of zoom up. You know, it's a lot of writing, but again, that's it. That's what we're going to do. Some of the key pieces, I would probably put the definition of p hat down here. So I would have done 22 out of 50 equals 0.44 down here. One thing is never put it up here. So what I'm going to tell you is these pieces right up here, P and H, will never, ever, 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 ever have any samples up here. It's always going to be based on a claim. So make sure you do your checks, make sure you write that sentence, make sure you show the calculations. If you do this down here, it does kind of support what you're doing in the problem by kind of using that boilerplate sentence. You really don't need to do it with the letters in it, but you do need to do it with the numbers in it. Get this number from the calculator, get this number from the calculator, and then kind of use that sentence. There's ways around other things other than using that sentence, but that's a pretty safe bet on how you use your sentences. So hopefully you enjoyed the class, hopefully you enjoyed Skittles, and hopefully Mr. Micah gave you a different sort of perspective on this information.